A diode is the simplest electronic device. There are many different types of diodes. Most of our semiconductor diodes, while many diodes have a different construction from the typical p-n junctions, all diodes are by definition two-terminal one-way voltage-controlled electronic bulbs. Signal diodes. Signal diodes are frequently used in electronic circuits. Often, the term signal diode is used to reference small signal diodes. They are designed to operate small currents and high-frequency signals, which is why they are commonly used in radio, television, communication, and switching circuits. These general-purpose semiconductor diodes can be easily identified by their relatively small size and are either glass-passivated diodes or point-contact diodes. In a glass-passivated diode, the p-n junction is encapsulated in glass to protect it from contamination. There is a red or black band on one of the ends to identify the cathode terminal. The power and current rating of signal diodes is minimal, typically 500 milliwatts and 150 milliamperes respectively. The signal diodes are best suitable for high-frequency applications or switching applications involving short pulse waveforms. The point contact diodes are slightly different in construction. A point contact diode is constructed by creating a p-n junction between a gold or tungsten wire and an n-type germanium material. The gold wire allows passage of high current through the junction point. Point contact diodes are used to detect high-frequency signals, as these diodes have the characteristics of blocking DC signals while passing the high-frequency AC. Almost all signal diodes are either silicon or germanium, but both types are slightly different in specifications. A silicon diode has high reverse resistance while a germanium diode has lower. The cut-in voltage of a silicon diode is 0.6 to 0.7 voltage, and a germanium diode is 0.2 to 0.3 voltage. Silicon diodes have lower forward resistance that allows high peaks of the same forward current and the reverse voltage. The symbol of signal diodes is the same as generic diodes. Small signal diodes are constructed as PS diodes with a tiny junction area. A smaller junction area gives the diode a smaller junction capacitance. This also reduces the reverse recovery time of the diode to few nanoseconds or less. Small junction capacitance and fast response make the diodes suitable for high-frequency applications. The simplest construction of a signal diode is infusing p-type silicon over n-type silicon. However, simple construction has less predictable specifications. Some of the common applications of signal diodes are as follows: wave shaping or clipping. Signal diodes are frequently used for clipping AC signals. One or more signal diodes can be used to clip an input signal. One signal diode can clip either only a positive cycle or a negative cycle. The use of two signal diodes can clip both cycles of an input AC signal. The signal diode bypasses the clip signal in forward bias condition if connected parallel to the input port. The unclipped output signal is obtained for the reverse bias period of the diode. If both cycles are shaped using signal diodes, two signal diodes are connected to the circuit in the opposite configuration. Therefore, one diode operates on one cycle and the other operates on the other cycle of the AC wave. The signal diode bypasses the unclipped signal if connected in series with the input signal. If the peak voltage of the AC signal is not much high, the forward voltage of the diode can have a significant impact on the wave shaping. Second, clamping and DC restoration. Signal diodes are used for altering the DC level of AC signals. This is called diode clamping or DC restoration. A clamper circuit essentially involves a signal diode and a capacitor. Diode clamping is often used in digital circuits to reset upper and lower limits of square wave signals to either communicate signals between two systems of different signal levels or for other specific requirements like adjustment of pixel brightness of a display screen. Protection diodes. Signal diodes are also used to protect other semiconductor devices and interfaces from sudden voltage spikes and excessive signal voltages. Such protection mechanisms are often required in control systems where semiconductor circuits or interface control high-power actuators. Freewheel diodes are widely used to protect semiconductor devices. A signal diode is connected in parallel to an inductive load, which is useful in suppressing voltage spikes and transients. Voltage regulation. In some cases, signal diodes can also be employed for simple voltage regulation. In forward bias region, a signal diode has a constant voltage drop across it. By connecting many signal diodes in series, a fixed voltage can be dropped from the input voltage. For voltage regulation, Zener diodes are a better alternative. Still, simple voltage regulation can be achieved by using signal diodes. Power diode or rectifier diode. The most popular applications of diodes have been explained, and one of them is rectification. Rectification means, in electrical terms, conversion of alternating current AC to direct current DC using electrical equipment. The alternating current is bidirectional, having positive and negative values, and the direct current is unidirectional, either positive or negative. The direct current signal should ideally provide a continuous and constant value. The rectifier circuits are mostly used in power suppliers, inverters, and battery chargers. The diodes used in high-power circuits are termed power diodes. Large signal diodes are different from small signal diodes in the area of their p-n junction. Large signal diodes have a larger p-n junction area. This increases the current carrying capacity as well as a peak inverse voltage. They have a very low forward resistance to reverse resistance ratio, with the forward resistance typically a few ohms while the reverse resistance is in mega ohms. That's why these diodes are not suitable for high frequency circuits. They have a large PIV rating, small forward resistance, and large current carrying capacity. These are generally used for AC to DC voltage rectification or to suppress high peak voltages. In fact, large signal diodes are mostly rectifier diodes. Power diodes are large signal diodes. These are specifically used for voltage rectification. The most important parameter of power diodes is their PIV rating. The PIV rating of power diodes typically ranges from 50 volts to 1000 volts. Maximum forward current and the forward resistance to reverse resistance ratio are other two important factors that need to be checked in a power diodes datasheet. Schottky diode. The Schottky diode is a type of metal semiconductor junction diode, which is also known as hot carrier diode, low voltage diode, or Schottky barrier diode. The Schottky diode is formed by the junction of a semiconductor with a metal. Schottky diode offers fast switching action and has a low voltage forward drop. As we are aware that in a p-n junction diode, p-type and n-type are joined together to form a p-n junction. Whereas in Schottky diode, metals like platinum or aluminum are used instead of p-type semiconductors. The VI characteristics of Schottky diodes are very much similar to the p-n junction diode. Current is the dependent variable while voltage is the independent variable in the Schottky diode. The forward voltage drop of the Schottky diode is low, between 0.2 to 0.3 volts. Working of a Schottky diode. The operation relies on the principle that the electrons in different materials have different potential energy. N-type semiconductors have a higher potential energy than electrons of metals. When these two are brought into contact, there is a flow of electrons in both directions across the metal semiconductor interface. A voltage is applied to the Schottky so that the metal is positive when compared to the semiconductor. The voltage opposes the built-in potential and makes the current flow easy. Applications of Schottky diode. Schottky diodes have been useful for the industry of electronics that has spotted many applications in diode rectifiers because of its unique properties. Here are some major areas where it is widely used. RF mixer and detector diode. The Schottky diode consists of its radio frequency functions owing to its switching speed at the highest level and top frequency capability. The Schottky barrier diodes come handy for diode ring mixers with high performance. Power rectifier. The Schottky barrier diodes also have functions with high powers as rectifiers. The high density of current and voltage drop with low forward shows that the wastage of power is lesser than the normal PN junction diodes. Power OR circuits. This diode would be useful for functions where two different power supplies drive a load, like in battery supply. It is important that the power coming from the supply should not mix with the others. Solar cell applications. As we know, the solar cells are usually linked to the batteries that are rechargeable, mostly batteries with lead acid since power supply must be necessary round the clock. Solar cells would not support the applied charge in reverse and thus a diode would be used in a proportional pattern of the solar cells. Light emitting diode. Light emitting diode is a widely used standard source of light in electrical equipment. It has a wide range of applications ranging from your mobile phone to large advertising billboards. They mostly find applications in devices that show the time and display different types of data. An LED or light emitting diode is a semiconductor device that emits light when an electric current flows through it. When current passes through an LED, the electrons recombine with holes emitting light in the process. LEDs allow the current to flow in the forward direction and blocks the current in the reverse direction. Light emitting diodes are heavily doped PN junction based on the semiconductor material used and the amount of doping. An LED will emit colored light as a particular spectral wavelength when forward biased. As shown in the figure, an LED is encapsulated with a transparent cover so that emitted light can come out. The LED symbol is the standard symbol for a diode, with the addition of two small arrows denoting the emission of light. When the diode is forward biased, the minority electrons are sent from P to N, while the minority holes are sent from N to P. At the junction boundary, the concentration of minority carrier increases. The excess minority carriers at the junction recombine with the majority charges carriers. The energy is released in the form of protons on recombination. In standard diodes, the energy is released in the form of heat. But in light-emitting diodes, the energy is released in the form of photons. We call this phenomenon electroluminescence. Electroluminescence is an optical phenomenon and electrical phenomenon where a material emits light in response to an electric current passed through it. As the forward voltage increases, the intensity of the light increases and reaches a maximum. The color of an LED is determined by the material used in the semiconducting element. The two primary materials used in LEDs are aluminum, gallium, indium phosphide alloys, and indium gallium nitride alloys. Aluminum alloys are used to obtain red, orange, and yellow light, and indium alloys are used to get green, blue, and white light. Slight changes in the composition of these alloys change the color of the emitted light. Laser diodes. Laser diodes can produce a narrow beam of laser light in which all the light waves have similar wavelengths. Because of this property, laser beams are very bright and can be focused over a very tiny spot. Laser diodes are widely used in various devices like barcode readers, laser printers, security systems, fiber optic communications, etc. A laser diode is a semiconductor diode that uses a PN junction for producing coherent radiation with the same frequency and phase, which is either in the visible or infrared structure. It is also called an injection laser diode, and the technology is similar to that found in LED. Characteristics of laser diode. The laser diode is characterized as follows: monochromatic, an insubstantial width of radiant narrow light containing only a single color. Well directed. In this type, the light will be directed into a narrow beam. It is easy to launch through an optical fiber. Coherent, a light with a single wavelength emitted by an LED and a wide wavelength. Double heterostructure laser diode. Heterostructure is a material that is sandwiched between two N-type and P-type materials. Because of the presence of heterostructure material, this type of laser diode is called double heterostructure laser diode. The main advantage of this diode is that the active region is used for better optical amplification. Quantum well laser diode. The quantum well is a very thin middle layer in the diode. The quantum energy is used for converting electrons from higher energy to lower energy and is responsible for better efficiency. Separate confinement heterostructure laser diode. There are two additional layers along with three layers. These layers have a lower refractive and the emission light is also improved. Vertical cavity surface emitting laser diode. In this type of laser diode, the optical cavity is along the axis of the current flow. Applications of laser diode. The following are applications of laser diodes. Consumer electrics. This includes laser printers, CDs and DVD players, and fiber optic communication. Industrial applications. When it comes to industrial applications, laser diode is preferred as it is a source of high-intensity laser beam and used for cutting, drilling, welding, etc. Medical applications. Laser diodes are used for the elimination of unwanted tissues and tumors and also in dental medication. Scientific instrumentation. Instruments like spectrometers, rangefinders, contactless measurements can be done with the help of laser diodes. The laser diode in telecom. Laser diodes with 1.3 micrometer and 1.55 micrometer bands are used as the main source of light in telecom, and as the band changes, laser diodes find application in optical amplifications. Photodiodes. A photodiode is a PN junction diode that consumes light energy to produce an electric current. They are also called photodetector, a light detector, and a photosensor. Photodiodes are designed to work in reverse bias condition. Typical photodiode materials are silicon, germanium, and indium gallium arsenide. A photodiode is subjected to photons in the form of light, which affects the generation of electron-hole pairs. If the energy of the falling photons is greater than the energy gap of the semiconductor material, electron-hole pairs are created near the depletion group of the diode. The electron-hole pairs created are separate from each other before recombining due to the electric field of the junction. The direction of the electric field in the diode forces the electrons to move towards the N side, and consequently, the holes move towards the P side. As a result of the increase in the number of electrons on the N side and the holes on the P side, a rise in the electromotive force is observed. Now, when an external load is connected to the system, a current flow is observed through it. The more the electromotive force created, the greater the current flow. The magnitude of the electromotive force depends directly upon the intensity of the incident light. This effect of the proportional change in photocurrent with the change in light intensity can be easily observed by applying a reverse bias. Since photodiodes generate current flow directly depending upon the light intensity received, they can be used as photodetectors to detect optical lights. Built-in lenses and optical filters may be used to enhance the power and productivity of a photodiode. Applications of a photodiode. Photodiodes are used in simple day-to-day applications. The reason for their prominent use is their linear response of photodiode to light illumination. Photodiodes, with the help of optocouplers, provide electric isolation. When two isolated circuits are illuminated by light, optocouplers are used to couple the circuit optically. Optocouplers are faster compared to conventional devices. Photodiodes are used in safety electronics such as fire and smoke detectors. Photodiodes are used in numerous medical applications. They are also used in instruments that analyze samples, detectors for computed tomography, and also used in blood gas monitors. Photodiodes are used in solar cell panels. They are also used in logic circuits, detection circuits, character recognition circuits, and also exact measurement of the intensity of light in science and industry. Photodiodes are faster and more complex than normal PN junction diodes and hence are frequently used for lighting regulation and optical communication. Pin diode. The pin diode comprises a semiconductor diodes having three layers, naming the P-type layer, intrinsic layer, and N-type layer. The P and N regions are there, and the region between them consists of the intrinsic material, and the doping level is said to be very low in this region. The thickness of the intrinsic layer is very narrow, which ranges from 10 to 200 microns. The P region and the N-type regions are known to be heavily doped. The changes in the properties of a diode are known from the intrinsic material. These diodes are made of silicon. The intrinsic region of the pin diode acts like an inferior rectifier, which is used in various devices such as attenuators, photodetectors, fast switches, high voltage power circuits, and etc. Applications of pin diode. Pin diode has a wide range of applications coming in various fields of physics like radio frequency switch, microwave switch, radio frequency attenuator, microwave attenuator, photodetector, etc. Some applications are given below. These diodes are used in the RF and also for microwave switches and the microwave variable attenuator since they are said to have low capacitance. They are also used in photodetectors and photovoltaic cells, and the pin photodiodes are used for fiber optic network cards and switches. These diodes are effectively used for RF protection circuits, and they can also be utilized as an RF switch. The pin photodiode is also used to detect X-rays and gamma-ray photons. The Zener diode. A Zener diode not only allows current to flow from the anode to the cathode but also in the reverse direction. Due to this functionality, Zener diodes are the most commonly used semiconductor diodes. In this article, let us learn the function of Zener diodes along with the construction, operation, and more. A Zener diode, also known as breakdown diode, is a heavily doped semiconductor device that is designed to operate in the reverse direction. When the voltage across the terminals of a Zener diode is reversed and the potential reaches the Zener voltage, the junction breaks down and the current flows in the reverse direction. This effect is also known as the Zener effect. A Zener diode operates just like a normal diode when it is forward biased. However, a small leakage current flows through the diode when connected in reverse bias mode. As the reverse voltage increases to the predetermined breakdown voltage, current starts flowing through the diode. The current increases to a maximum which is determined by the series resistor, after which it stabilizes and remains constant over a wide range of applied voltage. Avalanche breakdown versus Zener breakdown. Avalanche breakdown in Zener diode. Avalanche breakdown occurs in the normal diode and Zener diode at high reverse voltage. When a high value of reverse voltage is applied to the p-n junction, the free electrons gain sufficient energy and accelerate at high velocities. These free electrons moving at high velocity collide with other atoms and knock off more electrons. Due to this continuous collection, a large number of free electrons are generated as a result of electric current, and the diode rapidly increases. This sudden increase in electric current may permanently destroy the normal diode. However, a Zener diode is designed to operate under avalanche breakdown and can sustain the sudden spike of current. Avalanche breakdown occurs in Zener diodes with Zener voltage greater than 6 volts. Zener breakdown in Zener diode. When the applied reverse voltage reaches closer to Zener voltage, the electric field in the depletion region gets strong enough to pull electrons from their valence bond. The valence electrons that gain sufficient energy from this strong electric field of the depletion region break free from the parent atom. At the Zener breakdown region, a small increase in the voltage results in the rapid increase of the electric current. There are many ways in which a Zener diode is packaged. Some are used for high levels of power dissipation, and others are contained in surface amount formats. The most common Zener diode type is contained within a small glass encapsulation. It has a band around one end marking the cathode side of the diode. A Zener diode circuit symbol places two tags at the end of the wire, one in the upward direction and the other in the lower direction. This helps in distinguishing Zener diodes from other forms of diodes within the circuit. Forward characteristics of Zener diode. The first quadrant of the graph represents the forward characteristics of a diode. From the graph, we understand that it is almost identical to the forward characteristics of any other p-n junction diode. Reverse characteristics of Zener diode. When a reverse voltage is applied to a Zener voltage, a small reverse saturation current flows across the diode. This current is due to thermally generated minority carriers. As the reverse voltage increases at a certain value of reverse voltage, the reverse current increases drastically and sharply. This is an indication that the breakdown has occurred. We call this voltage breakdown voltage or Zener voltage, and VZ denotes it. Applications of Zener diodes. Zener diode as a voltage regulator. The Zener diode is used as a shunt voltage regulator for regulating voltage across small loads. The Zener diode is connected parallel to the load to make it reverse bias, and once the Zener diode exceeds knee voltage, the voltage across the load will become constant. The breakdown voltage of Zener diodes will be constant for a wide variety range of currents. Zener diode in over voltage protection. When the input voltage is higher than the Zener breakage voltage, the voltage across the resistor drops, resulting in a short circuit. This can be avoided by using the Zener diode. Zener diode in clipping circuits. Zener diode is used for modifying AC waveform clipping circuits by limiting the parts of either one or both the half circles of an AC waveform. And that's it for my presentation for special purpose diodes.